Welcome to the Tribano demo site of the GEOTeCH project, a Horizon 2020 project funded by the EU, and it's a consortium consisting of companies and also universities, in total 20 partners, with the aim to enhance and promote shallow geothermal systems. As you can see in the background here, we have a novel drill rig which uses hollow stem auger to install coaxial heat exchangers, and these heat exchangers will be used for heat pumps for heating and cooling of buildings, and doing this in a sustainable manner.
Shallow geothermal energy can be used to heat and cool buildings in Mediterranean and the European area. It can be done through the use of a geothermal heat exchanger with a closed loop system. Differences in ground condition can enhance or limit the potential of geothermal energy exploitation.
You are now looking at the drill rig, the innovative drill rig, which is developed in Work Package 2 in the GEOTeCH project. The drill rig uses hollow stem augers, which you can see in the back of the machine. And with these augers we install heat exchangers, coaxial heat exchangers, varying in depth between maybe 15 meters for the very big diameter heat exchangers to maybe 50-60 meters for the more slender type heat exchangers. And the innovation is that we have a drilling method that does not use water. It means you can go to site, you can quickly set up and drill. And for instance, yesterday we did a borehole, we drilled in half an hour, and it took us half an hour to install the heat exchanger. So in total an hour, which means on a working day you could do 8 to 10 boreholes. We are a relatively unexperienced crew. For us it's just the second day that we're working with the machine, but we're already getting quite good results. And this is part of the innovation, to make it easier for drillers, to attract new people to the drilling market, and to install heat exchangers in a more economical and more efficient manner, which will allow us to promote ground source and to have more ground source systems using the ground for heating and cooling of buildings, doing this in a sustainable way, because what we want to do, of course, is the CO2 reduction. We want better energy performance, so it is a future-oriented technology.
So this is one of the 3 prototypes of the GEOTeCH heat pump. This is prototype number 3, and at the moment this is a unique model in the market. Why it is unique? So first of all, it is a dual source heat pump. It means that we can use geothermal source, so the underground, by using vertical boreholes, but at the same time we can use the air as a thermal source. So we can decide what is the most convenient source in order to achieve the highest efficiency, and so the highest money saving and energy saving from the whole system. Then it is using a new refrigerant R32, which is one of the possible refrigerants which will replace 4 and 10A. So this is quite new at the moment. this is a full inverter-driven heat pump. It means that we have a modulating compressor. We have electronically commutated EC fans, and we have modulating electronic pumps. This means that the whole heat pump can be modulated according to the heat load or the cooling load inside the house, the user side. Last but not least, this is a multifunction unit, which means that we have a full recovery of condensing heating capacity. It means that instead of rejecting the heat in the air or in the underground, during the summertime we can use it, especially for hot water purposes, sanitary hot water. And in this case we can have cooling and heating at the same time. So you can imagine that with this kind of functionality, we can have a COP of the system, which is really, really huge. So in the end, we are studying this heat pump. We are testing it, providing some data to the other partners of the project, trying to achieve the maximum efficiency, not only from the heat pump, but from the system itself. And it's getting really successful.